Hey man, and welcome to What Do You Think About, a real-time voting app, a beautiful real-time voting app we are gonna build step by step together in this video. On the homepage, we can see how many requests we served, and this is updated actually from our database, right? This is a real value. We're keeping track of all the requests that we served in our application. And basically, the idea is we are allowed to enter any topic right here, for example, Redis. And once we hit create, that's gonna take us to a page what people think about Redis, where everyone can share their opinion about Redis updated in real time. And the main focus of this app is infrastructure, how to make this scalable, right? And instead of talking about it, let me show you. So let's go into a split screen view and let's go to the same page or Redis page once again. So we open this up side by side. Imagine these are two separate people connected to the same web app. And if one of them shares their opinion about Redis, like Redis is awesome, and then hits share, well, bam, there it is live in real time on this other client. And this could work if there were like 100, 200, 300 clients connected. It works really, really well. Redis is great. And there's this beautiful cloud of words that we're displaying in the middle coming from an Airbnb style library, right? So it looks great out of the box. If you're done making a presentation, for example, you can just share a link to this page and people can comment in real time what they think, and everybody is updated to what all the other people are thinking. And not only that, we're also keeping track of all the active connections in our database right here. So we can see there are two people connected right now to our app, right? What if we disconnected from one of them? Well, for there to be only one active connection to our Redis room. And we are keeping track of a lot of stuff, server side, everything that's interesting, right? How many requests did we serve all together? So we can display that on the landing page. What words are inside the Redis room or in any other room that the user connects to? It just works really, really smoothly out of the box. And if we now disconnect, well, what do we expect to happen now? There is no active connection in the room. And of course, we know about that because that's exactly what we're tracking. So what we're building step by step together in this video is a super fast, super performant, and mostly scalable, right? That's, as I said earlier, the main focus of this video, real-time application where people can share their opinion about different topics, goated. And there's going to be the principle of rooms, of connections, of real-time data, how that's sent around, how the infrastructure behind all of this works. And of course, I want to make sure you know how this works under the hood, right? So we're going to go through how this works like architecturally. This is a sketch from later on in the video because I'm recording the intro after I'm doing the entire video. And it's going to be really fun. So these are different users, how they connect to rooms and so on. That's what you're going to learn in this video. And of course, not only the infrastructure, the thought process behind how to build an app like this and how to make it work super reliably, but also just make it look good. Look at the background. There's a grid pattern in the background. Gonna pay attention to the colors, to the actual graphic that is displayed in the middle here using a accessible and good looking UI library, and just make this good. If you want to put this on your portfolio, awesome. So with that said, let's build this really, really cool application. I hope you're gonna have a ton of fun building it, and let's go. Alright dude, so let's get started, and this is gonna be a ton of fun to build. I'm gonna start here on my desktop. Let's create a new folder right here on Shrek's hand, and let's name this, I don't know, what do you want to call this? Let's say Scalable Redis. Maybe that's a bit cliche, but I guess you get the idea. Let's go into here and let's create two folders inside of here. First off, that's gonna be the client folder, and second off, that's going to be our server folder. So we're going to keep the logic for each one completely separately. Great. Let's open up our terminal. That's what it's called on Mac, because I recently switched over, or your CMD as I did for the last like 10 years on Windows. And let's navigate into this directory. So for me, that's going to be in the desktop, then the Scalable Redis, and then let's navigate CD into the client folder, essentially just opening up a terminal instance inside of the client folder, right? And then we're going to say pnpm dlx, or you can also use npx. It's the same thing, right? It's just a different package manager. So if you use npm normally, you're going to say npx. I'm going to use pnpm because the caching is a bit nicer, but it really doesn't matter which one you use. Pnpm dlx, create next app at latest. And then very important dot at the end to tell the pnpm dlx or npx, depending on what you're using, that we want to create the next app inside of the client folder, which is not going to ask us for a separate name, but it's going to put all the files in the client folder. Great. That's gonna ask us a bunch of questions. For example, do we want TypeScript? Hell yes we do. ESLint, yes for better code quality, that is nice. Tailwind, yes. Source directory, I like it, but it is very much personal preference. I prefer it definitely though. Would you like to use the app router? Yes, let's do it. And no, we don't want to configure the default alias. Beautiful. And that's a nice thing about PNPM. Look at this. It downloaded 0 additional packages. It drew it all from the kind of symlink cache, right? So how it works under the hood, if you didn't know, is it symlinks the dependencies. It doesn't download all of the dependencies into the node modules folder like npm would do. It kind of caches the dependencies on your PC in one central store, which is why it's a bit faster than npm. But again, it's not very important what you use. Beautiful. So let's open this up in VS Code. So I'm gonna say code dot. And what this means is that we want to use VS Code, right? The code in the current folder to open this up. That's why we have the dot. And all that's gonna do is open up the client folder, just this one inside of VS Code. And actually, you know what I prefer? Let's open up both. Let's say cd dot. So we're in the Scalable Redis folder, and then we're gonna say code dot, because then it's also gonna list the server directory alongside the client, which is gonna be useful in a second when we get started with the server. Before we do, let's make sure that everything in here works and looks nice. So let's try to start up our development server. Let's say yarn dev. Interesting, that didn't work yet. Oh, and that's because we tried to run that in the main directory. So we need to cd into the client, and then let's run yarn dev. So essentially we're telling the terminal that we want to execute yarn dev inside of this client folder and not in the overlying directory where also the server lives, right? Beautiful. That's gonna start up or development server on port 3000. Normally I already had something running. I just quickly went ahead and stopped it, and now it's running on localhost 3000. Great, let's open this up. Let's navigate to localhost 3000 and see what happens. And we should be able to see, beautiful, the blank Next.js page right here. Beautiful. That's exactly what we expect to see. Let's close out of this again. And the animations on how Windows close look so goofy on Mac. I prefer it on Windows. But anyways, okay, we can get rid of all the content that is inside of our main page.tsx. We can just mark it all, hit delete. We don't need any of that. And by the way, we can hit Shift, Alt, and O to get rid of all the unused imports, which is just a quick little hack if you didn't know how to do it. Beautiful. So dude, how about we just make this look good right away? Let's kind of open this up side by side so we get a better view here. Beautiful. Okay, now the first thing to make this look good already is let's open up one more terminal and let's say npx shadcn-ui at latest init. Now what that's gonna do, right? Oh, I wanted to mark this, that doesn't work, is basically it uses a UI library called shadcn-ui. That's just the name of the library, shadcn-ui, which is a pretty popular front-end library, if you've never heard of it, and it uses the latest version of that UI library, and we're initializing some styles, right? That's not gonna do too much to our project, and of course, this needs to happen inside of the client folder as well. This doesn't propagate to the server, this is just purely client-specific. So once we cd into the client, let's choose New York as the default style. We can go with Zinc as the base color, but it really doesn't matter. This is absolutely just personal preference. I just like the Zinc a lot. Would you like to use CSS variables for colors? Yes, we definitely want that. And basically all that's gonna do is it's gonna configure a bunch of styles in our globals.css that they just look good out of the box, right? So basically if we now go ahead in our main page.tsx and just put a little paragraph here, don't worry, we're gonna get rid of it in a second, but let's just see what happens. Basically, this is already gonna look pretty good, all right? I mean, is it perfect? No, because we only have a paragraph here, but it looks pretty solid as a start, right? And that's what our UI library kind of did. It evens out the colors and it gives us a really nice basis to work off of. Beautiful. Now, this main page.tsx under source app page.tsx is created by Next.js by default. And at the top level here in the JSX, we're going to return a section. Now, this section is going to get 2 class names, and let's give this a bit more space. And is there a way to go into nice split screen in Mac? I don't think there is. That's way easier on Windows. Yeah, sometimes Mac is a bit wanky, but anyways. All right, this section is going to get a class name of minimum height screen and then a background grid zinc of 50. And you're going to see what this does in a second. Once we add that, it gives like a really nice kind of grid background to the entire website. It's going to look very, very nice. And inside of the section is going to live a custom component that we're going to create together. And that's going to be called the Max with Wrapper. This is not going to be self-closing. Let's open this up. And of course, this component, Max with Wrapper, it doesn't exist yet. So let's create it in our components folder that our UI library created for us when we initialized it. Let's create a new file and call it Max with Wrapper.tsx. Now this Max with Wrapper, right? What does it do? It's a component that I use in literally all of my applications. It's super, super useful. And it's also super, super simple. Let's define a const and call it Max with Wrapper. And this is nothing more than an arrow function, right? So any React component that we export default Max with Wrapper here at the very bottom. Now the important thing is this takes two properties, right? It takes the class name and it also takes the children. So what's the purpose of this component? Basically, it wraps our entire page so we can reuse it across different pages, and it gives all the pages a even spacing from left and right side and top side and so on. That's why we wrap our app inside of it, and that's also why we receive the children as properties, which are going to be all the other DOM nodes that we'll have in React. Right? And to tell TypeScript what the hell is going on here, we need to tell TypeScript that the class name is optional and gonna be of type string, and that the children are gonna be of type React node. There we go. So basically just a div element, for example, or anything of that sort. Any React element is a React node. And in here, let's return a div element. This one gets a class name, and that's gonna be a dynamic class name. So let's put this in kind of curly braces. And inside of here, we're going to use a function that is cn. Now this comes from a local folder, but we did not create this function, right? We didn't write it. Where does it come from? It comes from our utils file right here under libutils. And this was actually created by our UI library as well. And the beautiful thing about this is it makes merging class names in Tailwind extremely easy. Let me show you how it works. When we use our cn function right here, we can pass it some default class names that will always be applied by default to this div right here, right? So let's say, for example, a height of full, an mx of auto, a width of full, a maximum width of screen XL, which I think is 1280 pixels if we hover over this. Okay, I probably don't have the extension that lets us hover over this. Anyways, let's give this a padding X of 2.5 and on medium devices a padding X of 20. There we go. Now, what did I mean by the default styles? Basically, if we want to override some class names wherever we render out the Max with Wrapper, like we do in our page.tsx, chances are we do maybe want to override some properties, right? And to do that, we need to merge the default class names properly with the incoming class name that we receive as a prop into this component, right? Because by default, merging class names in Tailwind doesn't really work, or the way that the underlying CSS file is generated for you, right? It doesn't merge well, and that's exactly what the cn helper function is for. It allows us to merge the default class name with the overriding class name if we decide to pass it. And then let's in here simply render out the children. So we're just wrapping essentially the app inside of a div to give everything even spacing. And as long as we now import or Max with Wrapper inside of our page and pass it any child, right? For example, let's just say a div element for now so the arrow goes away. TypeScript is going to be super happy with us, which is great. Now, let's actually make use of the class name on the Max with Wrapper. Let's give it a relative, a padding bottom of 24, a padding top of 10, on small devices a padding bottom of 32, on large devices a padding top of 24, on extra large devices a padding top of 32, and lastly on large devices a padding bottom of 52. There we go, beautiful. Let's go into the div we already created and give it a class name. And that class name is going to be hidden, large block, it's going to be absolute, and an inset of 0, which is the top, left, bottom, and right values just all together in one property. And lastly, a top of 8, because we do want a little bit of spacing on the top side. And inside of this div, this is where the decorative circle SVG animation is gonna live, but it's only gonna look really nice once we actually have content. So let's kind of comment this for now. Let's say circle, so we don't forget to do it later. But we do kind of need some content in here to be able to actually see the circle and have it look like really nice, you know? So I think it makes sense to do here in a second once we actually fill out the website content. And that's gonna happen right above the closing max with wrapper below this div right here. Let's open up the main div of this app. Let's give it a class name of padding x of 6. On large devices, a padding x of 0, and on large devices, a padding top of 4. Let's open this one up, and one more div in here with a class name of relative, mx auto, a text dash center, flex, flex dash call, and items dash center. And also open this one up. And inside of here is going to live our main heading, a heading 1 element with a class name, and that's going to be a relative, a leading dash snug, which is the line height, as you're going to see in a second, a width of fit, a tracking dash tight, which is the spacing between different letters, right? So we move them a bit closer together. And actually, let's already put the headline, and we're going to be able to see the class names in real time. I think that's nicer. Let's say, what do you think about inside of the headline? Let's save that. And oops, I didn't mean to move that. There we go. Why can't I just want to mark the headline, man. There we go. What do you think about? There it is. But it really doesn't look like a headline yet. So let's make that happen. All right, let's give it a text dash balance. Basically, as we break the text, it's gonna stay even. It's gonna look very nice on headlines. Then a margin top of 16, a font dash bold, a text gray of 900 to make it pretty dark, a text of 5XL to make it large, and on medium devices, a text of 6XL to make it really large. Beautiful. And that's exactly what the text balance does, right? If we didn't have this, check this out, it would look uneven. There's a lot of words on the first line and one word on the second line. With the text balance, bam, it evens out. It's balanced out. That's exactly what it's for. All right, now inside of this heading, let's actually make this look interesting, right? And if you remember the demo, there was like a little brain as the dot on the eye. And I think those tiny details look so cool in an actual app. So let's do that. Let's grab the think word and cut it for now, because we're gonna wrap it inside of a span element. Right, so let's put it back in here. Let's put the thing there. And this span element is gonna get a class name of white space dash no wrap, which means inside of the span, we don't want to break the letters, and because we're still gonna space this out even more, as you're gonna see, and that is gonna be just the letter I. So we're gonna cut that, put it in a separate span as well. And what that's gonna do is basically make our JSX look kind of funky, right? It looks weird, but it's gonna look really good once we're done with this. And the span wrapping the I will get a class name, and that's gonna be relative. There we go. And then the NK afterwards. And also inside of the span element, so inside of here, we're gonna put one more span, and this is gonna get a class name of absolute, an inset of 0, or an inset x of 0. That's what we want, just left and right, a minus top of 2, and a minus translate minus x minus 3. Right in here. And once we open this up, this is where the little brain goes that we want to show here as the dot on the I. And that brain is just nothing more than SVG. So we could just paste the SVG in here, right? The brain SVG. But I want to show you a really cool practice of how to use SVGs in your app. And that's basically a separate component that we're going to create in our source components. And let's name this file the icons.tsx. And these icons.tsx will let us keep track of all the SVGs in our app. So inside of here, we're going to say export const icons. And this is not a function. This is just an object, a plain object, very, very simple. And inside of here, we're going to have a brain icon that we're going to define as just an arrow function. There we go. And we can return the SVG from here. Now, dude, there's two options, right? What we could do is type out the SVG ourselves and write this. There is absolutely no point in doing that because nobody ever does that. What you do is go to the internet, grab an SVG you like, and then you use that, right? And to make the process easier for you, I prepared something called a copy-paste list. That's gonna be in the GitHub repository that I'm gonna link in the description for this project. And you can simply go ahead, go into the copy-paste list, grab this SVG. I'm gonna link the copy-paste list separately in the description, and just grab this first SVG. And I'm probably gonna name it something like brain icon. And then there's gonna be this SVG that you can simply copy and then paste right here into your icons.tsx. Now that is gonna give us a little error because first off, we need to return this SVG, and secondly, it doesn't know what these props are. TypeScript is not very happy. So let's tell it what it is. And the type of these props will be the HTML attributes that we can import from React as a type. And this takes a generic, and let's pass a HTML SVG. It's called HTML or SVG element. There we go. So basically we're telling React that it takes anything an SVG could take as props, right? So we can simply spread them into the SVG element, right? And then we can go ahead and save the icons and already go ahead and use those icons in our main page.tsx. So let's render out the icons.brain right here as the little dot of the eye. And to make this work, right, by default, it's kind of off, right? It's not exactly above the eye dot. Let's give this a class name, and that's going to be a height of 7, a width of 7, on medium, a height of 8, and on medium, a width of 8 as well, and then hit save. And as you can see, that overlaps the eye very, very nicely. And one thing we want to avoid is this little space bar that our IDE VS Code automatically put there. So let's get rid of it and save it. And there we go. Now we have a brain as the dot of the eye. That looks nice. Awesome, dude. All right, that's a very, very nice headline. Let's go ahead and continue right below our H1. This is where we're going to create a custom component, and let's call this component the topic creator. And that's going to allow us to create a topic and then get forwarded to that topic. So this is going to be our first entry point to our database, the first time we interact with our database, right? And of course, this topic creator also does not exist yet. So let's go ahead and create it. Let's say in our components, new file, and let's call it topic creator. .tsx. And you might be wondering, why are we doing this inside of a separate component? And the answer is that the page.tsx, or main component, is by default a server-side component in Next.js, right? By default, this is rendered on the server, which also means that we cannot use any hooks that React gives us, like state, for example, right? And in order to actually be able to use state, we need to opt into client-side behavior by using the use client directive at the very top of our file. Now we can use React hooks, and that's why we did this in a separate component, because otherwise we would have to mark the entire page as a client-side component, even though there is no client-side specific interaction needed on that page. So inside of our topic creator, let's say const topic creator is nothing more than a very regular arrow function that we export default topic creator right here at the very bottom. Great. Now inside of here, let's already go ahead and return. And at the top level, that's going to be a div element. Let's give this a class name of margin top 12. A flex-col, and a gap of 2. And let's open this div up and one more div right in here with a class name of flex and a gap of 2. There we go. Now, inside of the div element right here, we're gonna put a component that our UI library provides to us just to make it look good out of the box, right? We could, of course, write this ourselves, but let's not do that. Let's install this from our UI library. So what we're gonna do is go into our terminal and say npx shadcn UI or UI library at latest add, and we're gonna add 2 things, or let's say 3 things. We're gonna add the input, the button, and lastly the label, right? So those 3 things: input, button, label, and hit enter. That's gonna install 3 different components into our application, all of which fully accessible and looking beautiful out of the box. So let me show you what this does. Because we installed the input, we can now go ahead and import the input from our local components, because this put the code into our project, right? There is no abstraction here. It literally created a file in our project called input.tsx, right? So there is nothing we're importing from a library. This is just a file that was created in our project. That's why the zero abstraction policy of this UI library is so nice we can simply have the input as a self-closing thing. And once we import the topic creator in our main page.tsx, let's save that. We can see there's a fully accessible, beautiful looking input right here, right? Just like that, as easy as that, which is really, really nice. Right below that, let's put the button, right? Same logic. It's something from our own project that we can go into under components UI button. It created that button for us, which is awesome. And that button is going to say create. Right, we can already save that. All right, that already looks great. And into the input, let's pass two more things. That's going to be a class name of BG white and a minimum width of 64. And we can also give this input a placeholder. And let's say enter topic here, ... There we go. Let's save that. All right, that already looks so much better. Very, very nice. And now the last thing we need to do is to actually keep track of the input, right? So what the user writes in here. And we're going to do that in state. So let's declare a state and call it input and set input. And this is going to be equal to use state, a hook that we get from React that we can now use because we opted into client-side behavior earlier at the very top of the file, right? And this is just going to be an empty string by default. And just because of personal preference, I'm also going to pass a string generic into the state. TypeScript can definitely infer that this is a string. You don't need to pass this generic, but I like it. I think it is more readable if we actually pass it explicitly. Okay, and now to make this a controlled input, let's pass the value of input and also the onChange handler that we need to pass, where we can destructure the, oops, whoa, what did I do here? Where we can destructure the target right here in the callback function that we get, target, there we go. And we can simply set the input to the target.value. Beautiful. So essentially, whatever the user types in here is going to be the target.value as a string that we're setting into the input state, turning this into a controlled component, which means when we now hit the create button, something magical is going to happen. And that's going to be actually creating the topic inside of our database, right? Great. But I think before we do that, to implement the database logic, let's just quickly finish the landing page, right? I mean, we're almost done here. Let's just quickly go ahead and finish it. So below the topic creator, let's create a div element with a class name of margin top 12, a flex-call, on small devices, a flex-row, an items-center, on small devices, an items-start, and a gap of 5. Beautiful. Okay, let's open this up. Inside of here, one more div element. This one gets a class name of flex-call, a gap of 1, a justify dash between items-center, and on small devices an items-start as well. Beautiful. Let's open this up with one more div, and this one gets a class name of flex and also a gap of 0.5. And inside of this div is not going to be another div. Trust me, that's not going to happen. Inside of this div, we're going to make use of a super nice looking icon library. So let's go ahead into our terminal and install Lucid React. That is what the icon library is called. We can even look at it at lucid.dev. Beautiful and consistent icons made by the community, and they just look really good. There's like 1,500 icons in here that of course we don't have to use, right? But there's a lot of variety and they look great. And the icon that we're gonna use is the star icon from Lucid React. So let's go ahead and import that. It's going to be self-closing with a class name. And why does that not work? Why do we not get autocomplete on the icon? That is so weird. That never happened. Anyways, okay, let's just pass the class name like this then. Maybe TypeScript is just acting up. Let's give this a class name of height 4, a width of 4, a text green 600, and also a fill green of 600. There we go. Let's save that. And we should already see one star. Beautiful. And now we can just go ahead and simply grab this star element. And while holding Shift, Alt, and arrow down, let's hit that once, twice, thrice, and fourice. I don't know, like, so we have 5 stars, right? Using Shift, Alt, and arrow down. There we go. And it's kind of cut off here a bit. Maybe I can, yeah, there we go. Okay, so we have 5 stars below one another, and there they are. Beautiful. Okay, now with 4 more closing divs to go, and after one more closing div, let's open up a p tag here And inside of this p tag, there's gonna live a span element, and that's gonna get a class name of font-semi-bold. And inside of the span element, we're gonna list how many requests we actually served from the user, right? So let's just say 10 for now. We're gonna implement this here in a second, just so we can already say behind the close span element served requests. So that's gonna be the p tag, the served requests, and then we can style the number a bit differently. There we go. And we can also insert like a JavaScript spacebar, just like this, in curly braces. So we're gonna separate the 10 and the served requests. Beautiful. Of course, there shouldn't be hard-coded 10. We need to know how many requests we served. And for that, we need to know how many requests we served, right, from our database. And the database we're gonna use is Redis. So we're gonna head over to upstash.com. That's gonna be our Redis database provider for this video. And of course, like in all the other videos, full disclosure, hey, like I work here, right? That's how I can literally make these videos. It is such a nice platform for this like project. Otherwise I wouldn't use it, of course. And otherwise I wouldn't also just work there, because I really like what we do. And yeah, but it's important for me to be like transparent about it. Yes, I work here, right? That's the point. But it is like a really nice, fast, and also free database, right? You don't need any credit card to follow along, nothing. We can just go ahead and create a new database together. By the way, if you're wondering where I am, that's the Redis tab. Let's hit create database and let's name this real-time voting. Just for example, let's select a primary region. For me, that's gonna be closest to me. So that's gonna be Frankfurt, Germany. Just choose wherever is closest to you. And if you want, you can select a read region. I'm not gonna do that. And then that's it, create. Beautiful. That's gonna give us the credentials we need to connect to our database. And we're gonna head over to, where is it? Right here. The .env. So this is the two environment variables that we can just copy and paste over into our app. And let's create a new file in our app called the, in our client folder, by the way, the .env. And this is just a place where we can store these sensitive pieces of information where they cannot be accessed by the client side, but only by the server side, right? That's why we put them in a .env file. And what this allows us to do is to now actually connect to our Redis really, really easily. So how we do that is let's go into our lib folder, which stands for library, where a convention is that all files inside of the lib folder kind of prepare a library to be used in your app, right? And we're gonna create a redis.ts file inside of here. Now, using Redis is as easy as saying export const Redis is gonna be equal to a new Redis. Now, where does this Redis class come from? Well, there's a SDK we can install, npm install, and it's going to be called @upstash/Redis, which is just a wrapper around HTTP calls to Upstash Redis, right? Just fully type safe and everything. It's just nicer to work with as a TypeScript developer. And then we can import the Redis class from the just installed Upstash Redis and pass it two things. First off, the URL, that's gonna be, if you take a look at the environment variables, this one right here, the Upstash Redis REST URL. So we can pass in that as the process.env.upstash Redis REST URL. And then second thing is gonna be the token, that's gonna be the process.env, you can probably guess, right? Upstash Redis REST token that we just grabbed from the Upstash dashboard. Beautiful. Okay, let's give this more space and let's give this less space. There we go. Okay, perfect. So that's it, right? We can already use Redis, as easy as that. So what we want to do at the very top of our file, right here at the page.tsx, not the topic creator, this is a server-side component, as I told you about earlier. And what that means is we can actually make requests to our database because this is on the server, right? So let's say const served requests is going to be equal to await. And in order to be able to use await, we need to mark this as an asynchronous function, which again, we can because this is a server-side component. Redis, which we can simply now import from our lib folder that we just created, .get, and we're gonna get the served requests. There we go. That's already it. This is just how we're going to call it in our database. You're going to see how we increment that later for each request. And we can already go ahead and use that in our code right here instead of the hard-coded 10, right? That's not what we want, but we want a dynamic value right here. And what we're also going to do is we could just have the served requests as they are right here, but we don't really want to do that. Instead, we want to round the number to look better. So we're going to say math.ceil, which is going to round up basically. And we're going to say number and then put the served requests right in here. Because by default, they're going to be get as a string from Redis, but we want to convert them into a number right here. And then we can divide it by 10 and also multiply the whole thing by 10. So essentially we are rounding to the nearest 10, right? So if there's 101 requests, then we're going to say like 110 requests. It just looks a bit nicer if we round it up. Beautiful. Okay, that's already it. Dude, let's actually get started with the logic in the topic creator, because then we can actually see that the served requests go up with each request that we serve, right? And the logic in the topic creator is going to be really fun because it showcases one of my favorite data patterns or data fetching patterns of all time. And it uses a library, pnpm install, in our terminal. And that's probably one of the most popular React libraries of all time at tanstack/react-query. Right? It's a library that makes working with data, fetching and manipulating data extremely easy and also just really, really fun. And in order to be able to use Tanstack React Query, or formerly just React Query, right, in our application, there's one small thing we need to do, and that's create a providers.tsx component in our components. And the purpose of this providers component is to provide our entire app with a context, pretty much, if you're familiar with React context, right? So what we're going to say in here is const providers is nothing more than an arrow function that we can export default providers at the very bottom. Now, the only thing this does is return something called a query client provider, right? So essentially what we're doing is we are going to receive the children in our providers, which is going to be our entire app pretty much, right? So let's type this. The children are going to be of type, and you might know this by now, React node, right? For example, like a div element, and that div has then children again, and so on. And essentially we're just wrapping those children in a context provider. That is the query client provider. And this takes one thing, if you get the IntelliSense right here, and that's the client, right? And the client is simply, let's say const client at the very top right here is going to be equal to a new query client from React Query. Now, if you don't understand what this means, it's really not important. You do this once in your app, you initialize the client, which is basically super handy for caching, because we only declare it once in one point in our app. It can handle all the caching throughout the entire application. That's why we do it here, right? That's why it's so useful. And then we wrap our app inside of it. So every single time we call React Query, it uses the same client, all right? And not a new one. So it's great for caching, but it's also not that important. We do this once. I always just copy and paste this code, to be honest. I don't really write this myself for new projects because you don't need to think about it. It's very, very straightforward. And that's literally almost it. The absolutely last thing we need to do is to wrap our layout with these providers now, right? So we're gonna cut out our children. By the way, if you're wondering where we are, it's source app layout.tsx. This is where we are, right? And then we're simply gonna wrap the entire app inside of our providers, just paste back in the children. Oh, and one more thing, yeah, that's gonna give us an error, I know, is wrap the providers inside of a, or not really wrap, but declare them as a client-side component, because context is a client-side React hook, right? This can't happen on the server, which it would be by default. Beautiful, dude. And now as for my favorite data fetching pattern that I made a video about like a week ago, on my main YouTube channel, because I like it a lot. So how this works basically is, let's go inside of our topic creator and let's destructure something from the use mutation React query hook. Now, if you've never used React query, this sounds fancy. Use mutation, whoa, what is that, right? But as you're gonna see, it's very, very simple. All this takes is an object, right? And basically what it's meant for is post requests, right? For manipulating data. Otherwise, we have the use query. This is for getting data, but that's not what we want. We want to manipulate data, right? That's why we use the use mutation. And all this takes is something called a mutation function. And normally, right, this would be, don't follow along right now, I'm just showing this to you. Normally, this would be any kind of fetch request to your API where you pass like a method of post and then the post body and so on, right? It just takes a function that makes a fetch request. But in Next.js, there's something much, much cooler that we can do. And that will happen inside of a new file that we're going to create. Let's just create it in our app folder right here. And let's call it actions.ts. And basically, what we can do inside of this actions file is really, really cool. First thing we want to do is declare this as a use server, as a server-side file, right? And as long as we do that, all functions that we create in here, like for example, let's say export const create topic, and this is nothing else than an arrow function, this will now run on the server as an API route, right? Just abstracted in a way that is extremely nice. And this is fully compatible, by the way, with React query. So what we can do is simply use this RPC function as our mutation function right here in the topic creator. And well, TypeScript is not happy with us, probably because we didn't return anything. Yep, that's the case, but we're gonna do that in a second. Anyways, what we can do now is destructure first of the function to actually invoke this from the client side, right? Secondly, the error, and thirdly, the is pending, which is basically the loading state. Is this currently running? So we're outsourcing all the annoying work like error states, loading states, and so on to React query and get this beautiful developer experience for full stack type safety with the server action, right? Because if we now expect any kind of data in our server action, like for example, let's mark this as an asynchronous function, and let's expect the topic name, right, that we want to create this with. And of course, we also need to tell TypeScript what that will be. And that's going to be a string, the topic name, right? And as long as we return anything from this function, or in our case, what we're going to do is to redirect the user from next/navigation, that's where we get it, to, and then as a dynamic string, let's insert slash and then the topic name. So basically, if the topic name is Redis, for example, then we're going to redirect them to /Redis, right? And this is the base URL, so this would be localhost /Redis, or this would be your production URL if you wanted to deploy this, right? So that's all we're doing, and then you can already see the error is gone. Beautiful. And this already works, right? As easy as that. This is super, super nice, but of course we want to handle a little bit more logic than that. For example, what we want to do is to check if there's anything invalid in the topic name as kind of a server-side validation, right? That is really, really important to do. So we're going to define a const regex. And don't worry, it's going to be a very simple regular expression if you've never worked with them. So we're going to mark the start using this up kind of indicator. I don't know what it's called. Then in angled brackets, we're going to put smaller case A to Z and larger case A to Z. Right, so all letters are allowed, and also a minus, so hyphens are allowed as well. And we're going to say plus $sign at the end, which marks the end of the regular expression. Right, so all that's allowed are letters and hyphens. That's essentially what the regex says. And if we don't have a topic name, or let's say, or there we go, the topic name dot length is larger than 50. In that case, it's invalid, right? Either the user didn't provide a name for the topic, whatever they wrote right here, or it's like super, super long. They're trying to spam our API or whatever, right? So in that case, we're simply going to return an object with an arrow property that says name must be between 1 and 50 chars, right? Because we're not going to let that happen. It's just either too long or it wasn't provided at all. And now for the case where it's invalid, right, where it has like numbers or whatever the regex doesn't allow. If not regex.test, that's how we can test our string that we get against our regular expression, right, by calling the .test topic name. In that case, it's invalid, right, according to our regular expression. So same thing, we're going to return an error, and this is going to say only letters and hyphens allowed in name. Beautiful. And that's the extent of our server-side validation. And lastly, we're going to say await Redis dot, and we still need to import or Redis client for this to work. Basically, we want to save this topic in our database to keep track of all the existing topic across the entire application, right? So we're going to say redis.s add. So we're adding this to a set. And a set is nothing else. Let's say const set. You don't need to follow along. I'm just showing this to you like this, right? A new set, it's a built-in data type that doesn't contain duplicates. So if we said set.add, for example, hello, and we did this again, right, there wouldn't be 2 hellos in the set, but only 1, because a set in basic JavaScript as a data pattern doesn't allow duplicates. And in Redis, it's the exact same thing. If there's one topic, then there can't be duplicates of the same thing. And we're going to add this to the existing topics set. And what do we want to add? Well, the topic name, right? So this is how we call it in our database, and this is what we add to that set. Let's save our actions.ts, let's save our topic creator, and let's see if this works, right? So we actually need to use these functions in our topic creator, but that's super easy. But we already did all of the work for that to work, right? So for example, the disabled state we're gonna pass in the button is gonna be the is pending. So if we are in a loading state, the button should be disabled, of course, right? So the user can't spam it. And one more thing, that's going to be the onClick handler. What should happen once a user clicks the button? And that's simply going to call our mutate function. So essentially, the mutate function just calls the server-side function, but in a way where we can call it from the client side, right? So basically, all we're doing here is invoking the create topic function. Basically, same thing. That's why the arguments we need to pass in here are also the same. For example, this expects the topic name, right? And that's why this is such a beautiful data pattern. It's fully type safe across the stack, right? You see this? The parameter that we expect in the create topic function is immediately required as an argument on the front end. And that is super, super cool. And the topic name is going to be our input, just like that. Beautiful. And one more check we can do just for nice kind of user experience is if we have an error at the very end here, in that case, we're going to render out a p tag containing the error.message, right? If anything went wrong. And in the other case, we're just going to render out null. And this p tag is going to get a class name, and that's, oops, not an onClick handler, a class name. And that's going to be a text of small and a text red of 600, just to indicate that, hey, something went wrong here. Beautiful. Let's save that and see what happens. So what do we expect to happen? 2 things, right? When we enter a topic here now, let's say, for example, I don't know, Next.js, and then we're going to hit create. What we expect to happen now is to be redirected to a 404 page. Because /Next.js, what we are redirecting to, right? Right here, it doesn't exist in our app, but that's what we're going to create in a second. Beautiful. So that works, right? We got redirected to the /Next.js. Beautiful. We can see that in the URL. That worked. Let's go back. And then in our database, what we expect to see is that for the existing topics, we now have Next.js as an existing topic. Beautiful. So the database integration fully works, we know that, and the redirecting mechanic of our topic creator also works. Very, very nice. One small thing I just noticed that's not related to the data fetching logic is that we don't have the grid background that looks really, really nice. And how about we just quickly implement that? It's really simple, but I think it's gonna make it look so much nicer while we develop this app. It's these small things, man, like the background that make the app look so nice. So let's quickly do that. And where are we going to do that? Well, in our tailwind.config.ts, let's navigate over here. It's at the root of our client folder. And if you remember, we already had the class name for this, right? In our main page.tsx, the bggridzinc50 that we created, right? So this is a super nice way of writing your backgrounds that I want to show you. And we're going to write a custom plugin for this, but don't worry, it's actually really, really simple. So how this works is we can pass a function in here, and this function receives basically 2 things that we can destructure. Let's open this function up already. And what we are going to destructure are 2 things. It's going to be the match utility, and it's also going to be the theme. And let's just cast this as an any type to prevent any kind of TypeScript errors. It doesn't matter. And let's call this match utility function. And this takes 2 things, right? This takes an object at first and an object at second. And the first object this takes is whatever we want to call the class name, basically, right? So this is going to be a BG grid, how we want to call this. And the value that automatically gets passed in here, let's also just cast this as any, it doesn't really matter. Let's receive it and then return an object right here, inline, right? And as the second thing this takes, this is going to be a configuration, kind of, and this takes the values. And this is going to be flatten color palette, which is a function where we have yet to import. It doesn't exist, but we're going to import it here in a second. We're going to call the theme function, also from Tailwind, by the way. And in here, we're going to pass the background color. And lastly, let's comma separate this. The type is going to be color. Now, where does this flatten color palette come from? Well, basically, we can import it from Tailwind. It's a provided utility function for us. We just simply need to grab it. Let's say const default, and let's name this the flatten color palette is going to be equal to require, and let's require this from Tailwind CSS /lib/util/ and then flatten color palette. That's where we just grab it from. It's a function we can call from Tailwind that is completely provided to us. Now, as for the actual stuff that should show up when we name something a BG grid Zinc50, for example, that's what is determined right here in this first kind of block of the match utility, right? And we could write the SVG for this ourselves. Again, I don't think there's a point doing that. Instead, what I prepared for you, this looks really ugly, like in the copy paste list I have here, but it's gonna look nicer in your version. So head up into the GitHub repository, into the copy paste list, simply go ahead and grab that, and we want to return that as the background image and simply paste that URL in. And as you're gonna notice, we use one little utility function here, the SVG to data URI, and all this allows us to do is to have an SVG right here and convert it to something that the URL parameter of CSS understands, right? It's very simple. We could write this ourselves. It's not rocket science by any means, but there is a small library that does this for us, and we can just install it. It's just a lot easier. So let's say npm install, and this is called mini SVG data URI. And hit install. As you can see, that it was super fast. It's a very, very simple, very lightweight package. And it just does that utility for us. So let's import it. Let's say const svg to data URI is going to be equal to require, and then the package we just installed, mini svg data URI. And just like that, the error is gone. Let's save that. And what happens? We're getting a fail to compile. I think I did a little typo. It's match utilities and not match utility. There we go. Let's try this again. Let's reload our page. And there we go. That should work. And like 1 minute of debugging later, I was kind of confused why it didn't show up here on the right-hand side. And it does, but we do need to change the width and the height to 32 each. And then we can see the grid in the background. Very, very nice. Awesome, dude. I mean, writing your own Tailwind plugin, maybe not the most intuitive. Yeah, it's really not the most intuitive because you don't get the type safety, but you do this once, right? You just kind of do this once, then copy and paste it across your projects and never have to worry about it again. And then it just works, you know? So we can close out of the Tailwind file. We now have a beautiful background, and we know that our topic creation works. So if we put hello and hit create, then we are redirected to the page where we can vote. That is so nice, man. And of course, now this page doesn't exist yet. So let's go ahead and create it. In our source folder under app, let's create a new folder and name this in angled brackets the topic. And this is just the syntax in Next for a dynamic route, basically. So we're going to create a new file in here called page.tsx. That's going to actually control the content that is visible when we navigate to here. And the goal here, let's say const page, is nothing else than an arrow function that we export default at the bottom. The goal for this page is to simply grab what we passed as the slash, right? So when the user navigates here, they are at a path like slash Redis, right? Or slash anything. It doesn't really matter, right? And that's what we catch in the topic, and that's the piece of data we want to read in our page to actually get the database content for this page, right? The way we do that in Next is pretty easy. We can simply grab the params from a dynamic page, and these are going to be of type, let's name them page props. And let me show you how this works. So let's define an interface page props. So tell TypeScript what's going to be the type of these params right here. And the params are simply going to be an object where the topic is a string. Now, how do I know that? Basically, the rule is whatever's in these angled brackets right here is going to be the param name, right? Whatever you name this is going to be the same name as this. And we named the topic, so that's going to be the topic. And that's going to be the slash anything or Redis or whatever the user typed in is their topic name, right? So if we wanted to try this out, let's just return a p tag. And let's say the params.topic lives in here. What we expect to happen, right, is now as we save that, when we navigate to something like slash hello or slash Redis, let's say, then this should say Redis right here. And I didn't mean to move the thing. There we go. Now it says slash Redis because that's the params.topic value that we now receive dynamically in our page.tsx. As you can see, pretty easy, right? And we can simply go ahead and destructure the topic from our params. I just think syntactically that looks a bit nicer to work with in our page. So what's the purpose of the page? Basically, we need to fetch data from our database. What is that data gonna be? Well, it's basically gonna be an array of objects. There we go, where each object has a text, for example, hello, which is gonna be one single word, and a value of how often it is present in our data set, right? For example, 5 times. And that's how we later on determine the size of the word in the cloud of words. And basically, we just have an array of these objects saved in our database that we now want to get so we can render them out in the page, right? So that's pretty easy. And with Redis, especially easy. Let's say const initial data, because we're going to pass this data as the initial data into our client-side component, as you're going to see in a second here, is going to be equal to await redis.z range. The Z range allows us to get items from something called a sorted set. You're going to see more of this later as well. And in order to be able to use the await keyword, we need to mark this page as asynchronous. There we go. Now, inside of the Z range, we're going to pass a couple of configuration stuff. For example, the name of the set that we want to grab stuff from. This is going to be room, and then the topic. And this is just a Redis naming convention you're going to see a lot when working professionally with Redis, where there's like a classifier, a colon, or any other separator symbol, and then a dynamic value right here. It's just a convention to work with Redis. We want to grab values from 0 to 49, which basically means we want to grab the first 50 elements. The reason for this is that we never shoot like some insane amount of data into our client-side page, right? We just keep it until 50 entries, that's the maximum. And lastly, we're gonna say with scores is gonna be true, because that's gonna include the scores, right? So basically how this looks conceptually, if we open up Scalable, if we had 3 words, like for example, Redis is, and let's say great in our database, right? Then each one of these will have a score. For example, Redis is gonna have a score of 3, is going to have a score of 2, and great is going to have a score of, I don't know, 6. Doesn't really matter. And this just means how often did the word occur? How often do we have it in our database? So great will be the largest word in our cloud of words, right? Because it happened, or it was contained the most often. And is going to be the smallest word because it was said like the fewest amount of times. So these are the words that the people comment in our app, right? And this is going to be, let's name this the score, right? And this is called the member. Member. There we go. And that's just how Redis data types work. That's what they're called in a sorted set. So you understand, what we're doing here and why we're doing what we're doing. And this is how we grab data from our sorted set. Beautiful. Now let's determine how often each word occurs in our custom format that we expect in our rendering engine later on. Let's say const words. And this is going to be an array of a text string and a string and a value that's going to be a number, how often this word occurred, array. And let's default this to an empty array. And basically we want to go over our initial data and format it in a way that matches this right here, which makes it much easier to render out later. Because by default, what we get back from Redis looks something like this. It's just one array, and it has the key, which is going to be Redis 3, is 2, great 6. So it's these pairs, right? Redis 3 is 2 and so on, but they're all in one array. They're not in object format, so we need to kind of reformat them right here. That's going to happen inside of a for loop that we're going to create. Let's name the iterator just I, and let's go to the initial data dot length. Now, inside of the for loop, let's destructure two things, right? Because these are pairs, we only care about pairs of 2, right? So we can destructure 2 elements from an array, the text and the value, right? Text and value, text and value, and so on, from the initial data dot slice, and we're going to slice from I to the I plus 2. Right, so essentially we're going to have this as our for loop, this as our for loop, and this as our for loop saved as these two variables right here by array destructuring. And if the type of text is triple equal to string, and the type of value is triple equal to number, right here, which is just a check we do to make TypeScript happy. We know this will be the case, right, from looking at our data, but TypeScript doesn't really. We're going to say words.push, and we're going to push an object that contains both the text and the value right here. So we're just reformatting, as I mentioned earlier, into this format from this format, which just makes rendering out this whole thing so much easier, as you're going to see later. Beautiful. And now what we're also going to do is say await redis.increment increment the served requests, right? So if any user views a page, then we want to count that as a request that we serve. And similarly, if they comment something on a page, that will later also be a request, because after all, both of them are just user requests, right? So we can put them in one bucket. Beautiful. Very, very nice. Last thing we want to do is to return something called a client page from the main page.tsx. And the reason we do this is because a lot of the logic that's going to happen on each page right here is going to be client-side, actually, like the WebSockets, the real-time connections that we're going to open, or the one real-time connection that we're going to open here, that is going to happen client-side. And again, by default, as you can see right here, because we're interacting with our database and so on, this is on the server. So we can pass the initial data from the server to the client, which is an absolutely beautiful pattern in Next that I want to show you. So let's create a new file inside of our topic route called the client page.tsx. And the reason we put this here, this is just going to be a regular component. Why don't we put it in the components? Because this is not a reusable component. It's meant to be used with our page.tsx, right? It's not supposed to be reusable. We don't want it to be. That's why we put it here. Just co-locate those two. Beautiful. Okay, now in here, let's say const client page. And by the way, we can already mark this as a use client at the very top of the file, because this will just be client side to interact with the socket logic later on, right? To connect in real time to our server from the client. And as always, this is nothing more than an arrow function that we export default client page at the very bottom, right? Beautiful. Okay, now this client page takes two things as properties. That's the entire reason we fetch them on the server side beforehand, right? This takes the topic name and also the initial data that we want to render out on the client side. And to tell TypeScript what the type will be, let's name this the client page props, and of course also define the interface, whatever we named this, client page props. And this interface will have a topic name that's going to be just a string, and this will also have the initial data as we defined, and we know what type this will be. This is going to be an object containing a text string and a value of number array, right? That's already it. We can just open up our client page, and what we want to do first thing is to put this initial data into state, because later on, as the user comments and interacts with this page, the state can change, but the initial data, what we got from the server, should serve as a starting point for this page, right? So let's declare a state. Let's call it words and set words, and this is going to be equal to use state, a hook that we can import from React. And we can pass the initial data into this use state right here, which now allows us to not only get the data once we load the page, right? It's already gonna be there because we got it from the server and pass it into the client side right here, but we can now also modify it and reflect those changes on the client later on in real time, which is really, really nice. Awesome, dude. All right, let's return from this component at the top level a div element. That's gonna get a class name of with full, a flex, flex-call, items-center, justify center, a minimum height of screen, a background grid, a background grid of zinc 50, and a padding bottom of 20. Beautiful. Let's open up this div, and inside of here goes our max with wrapper to kind of get the even spacing as we had on the home page, right? That's what we have it for. And this is gonna get a class name of flex, flex-call, items-center, a gap of 6, and a padding top of 20. Okay, let's open up this max with wrapper, and inside of here lives an h1, a heading 1 element. And this is gonna say what people think about. And this h1 is gonna get a class name that's gonna be a text of 4XL, so pretty large. On small devices, even larger with a text of 5XL. Then a font-bold, a text center, tracking-tight, and a text balance. There we go. Now, we're also gonna put a span element in this h1, and now we're gonna dynamically insert the topic name into this span element. So what people think about, and then whatever the pages you're on, right? Dynamically insert right here, which is gonna look really nice. And it's gonna look even nicer if we give this a class name of text blue 600. So it kind of sticks out. So if we save all of this, right? And then we reload, and we also import our client page in our page.tsx in the dynamic route right here. This is where we are, app topic page.tsx. Now this also, of course, expects 2 props. That's going to be the initial data and also the topic, the topic name dynamically. Then, wow, we're going to get 2 errors already. Okay, so the topic, yeah, we just call this topic, all right. Number 1 fixed, right? 1 error left, and that's going to be the initial data. What is the problem? Basically, TypeScript doesn't know what is the stuff that we get back from Redis, right? So what we know that what we get back from the initial data from Redis is going to be an array of text and numbers. TypeScript doesn't know that. TypeScript just knows this is unknown, so it has no idea. So we can pass it the generic into here to tell TypeScript this will either be a string or this will be a number, and we're going to have an array of those. And that should get rid of the error, but it doesn't. And dude, of course, we need to pass the words as the initial data and not the initial data. So the formatted version of the initial data is gonna be passed into here. And just like that, the TypeScript error is gone. Beautiful. And we can now save that and reload our page. What people think about Redis. Very, very nice. By the way, I think one thing that looks a bit better is if we insert like a JavaScript space there. There we go. What people think about Redis. That looks a bit nicer. And how about we just put a little colon at the end here as well. There we go. There it is. Very, very nice. All right, dude. Now below this h1, let's quickly create a p tag. And this is going to say in parentheses, updated in real time. Just to kind of drive the point home that yes, this will be a super nice real-time WebSockets application. And let's give this a text small class name, just so it doesn't stick out too much and it doesn't take away from the main heading, right? Beautiful, dude. And now comes the coolest part of this page. Not the coolest. The coolest is going to be the real-time functionality, but the second coolest, and that's going to be the word cloud that we're going to have in here, right? And this word cloud we could do ourselves, but there's a library provided by Airbnb VizX, it's called, that looks great. That's going to provide this to us. It's like a UI library made by Airbnb. And I could show you around this library. There's a ton of stuff in here. Basically, the only thing we're going to need from this, by the way, almost 20,000 stars. Awesome. The only thing we're going to use of this, I think, is at the very bottom right here, the word cloud. It looks absolutely awesome. We can kind of play around here with how it looks. And that's what we're going to use for our app, right? So let's go ahead and install this Airbnb UI library. Let's say pnpm install, and that's going to be at vizx/, and that's going to be the word cloud. And while we're already here, we can also install some helpers. That's going to help us make this look a lot better. For example, at vizx/text and also at vizx/scale. And those utilities, the text and scale, are just going to make it much simpler to work with the word cloud and have the text be the right scale and so on. So it just looks a lot nicer than if we do it ourselves, right? Beautiful. All right, so below the p tag, above the closing max width wrapper, let's create a div element with a class name of aspect square, so an aspect ratio of 1:1. And dude, now the hovering works. Earlier it didn't work. That's so weird. Anyways, a maximum width of XL, a flex, items dash center, and justify dash center as well for horizontal alignment. Beautiful. Inside of here, we're going to use our word cloud, which is a component that we can simply import at the very top from import word cloud from the library we just installed, which is at visx/word cloud. There we go. Now, this word cloud expects a couple of properties. For example, it expects the words, right? And we already have those. These are our state or initial data that Airbnb expects in this format with text and value. That's why we formatted them that way. Let's give this a width of 500, also a height of 500, so it's going to be even. The font size is going to be, well, this would be a bit more effort to implement if we try to do it ourselves, but with the utilities that we also installed from the Airbnb library, this is actually really easy. So this will determine how large is each word going to be. And to do this, let's go above our return statement right here. Let's say const font scale. So how large should the font be? This comes from a scale log function that we can also import from Airbnb. Let's say at the very top, import scale log, and that's going to be from at visx/scale. There we go. Then we can go ahead and simply use that to determine how large each word should be. And the question is, well, how large should each word be? How do we know? And the answer is basically there's going to be, if you take a look at our data, right, we're going to have a bunch of text and a bunch of values. And the size of each word depends on the minimum, or I should mark this, minimum and maximum value that we use as a reference for scale, right? The largest value should be the largest word, and the smallest value should be the smallest word, and everything in between should be scaled according to that maximum and minimum. And the scale log actually respects that, right? What we can pass in here is an option, or an object rather, that takes a domain. And in here we can just specify two things, right? So let's open up an array right here. We can specify the minimum and the maximum. So the minimum value of our data is going to be the math.min from our ... So we're spreading in the words.map, and basically for each word, we just care about the word.value. There we go. So we're just creating an array of all the values that we have in the words at maximum 50, right? That's why we limited that in the parent component. And then the second thing in the array is expected to be the maximum. So the basically same thing, just the math.max in this case. And we can just simply grab the same logic where we spread in the words and just create an array from the values and paste it in here. So essentially we're giving Airbnb UI library the minimum value and the maximum value. And let's also give this a range. And that's going to be from 10 to 100. And that's just going to make the font scale between the sizes of 10 to 100. So it never exceeds those. Beautiful, dude. And just like that, we can now know what the font scale should be, because this is nothing else than a function, right? The font size where we get some data. And we can now simply call the font scale with that data.value. There we go. And just like that, we know how large each font should be. Very, very nice. This takes, for example, also the font. Let's say this is gonna be, in this dynamic syntax kind of here, impact. You can just specify the font family that you want to use. Then the padding, let's give this a padding of 2, just looks a bit nicer. The spiral is gonna be, and that's as a string, Archimedean. You can kind of tell the difference here from the Airbnb website. If we open this up, the Archimedean kind of looks like a brain, which I think is really cool. We could also go for a rectangular, but I much prefer this. I think it looks a lot nicer. That's why we put it there. The rotate is going to be 0. We don't want to rotate this. And also we can give this a random of 0.5, which just brings a little bit of randomness into the mix. Beautiful. Now, why is this still giving us an error? Property children is missing, yada, yada, yada. Essentially, what the word cloud expects us to do is, well, this is nothing else than a function, right? This gives us access to a callback function inside of this component in which we can grab the cloud words. So basically each word that is in the cloud, and it is now our responsibility to render this out, which is great because we can render this out however we want, right? For example, by saying cloudwords.map, and for each word that we get in here and also the index of the word, we're gonna just render out some JSX right away, right? So the parentheses right away. And what do we want to render out? Basically some text. And we can already grab this from @visex/text right here. This is not going to be self-closing because it is going to contain the word.text that we have in here, right? So for example, each word that we have here, that's gonna be our word.text that we render out right here. Because we're mapping, we're gonna need to pass this a key, for example, the word.text, because this is gonna be unique. The fill is basically just going to be the color that you want this to be. And we could just hard code this as a string, but what's much cooler is let's declare 3 different colors at the very top. And that just looks really nice visually. So it's not all the same color, but multiple shades of blue, right? So let's declare them. Let's say const colors is gonna be equal to an array of strings with hashtag and then 143059. These are just some colors that look nice that I got from Airbnb. Then second one is going to be hashtag 2F6B9A. And again, this could be any color that you want. I just think these look kind of nice. And then lastly, hashtag 82A6C2. There we go. So just some hex color codes right there. And we can use that to give this text its fill property with the according colors, right? So what we can do is say we're going to fill this with the colors array at the index of I modulo and then the colors dot length. There we go. Beautiful. Okay, the text anchor we're going to pass in here is going to be, let's say, middle. There we go. Let's go into the new line. The transform property of where the word should be is gonna be dynamic as a template string. Let's say translate, and then in parentheses, we're gonna put both the word.x, and this is a value provided to us by Airbnb library, right? That's why it's so easy to work with. And then we also want to pass in comma the word.y value. So this basically determines where in the cloud the word will be shown, right? The font size is going to be the word.size, and that's also provided to us, right? Very, very nice. And the font family is just going to be the word.font, which is going to be impact because that's what we specified right up here. Beautiful. Let's see if this works, right? We are done with that. Let's see. And well, okay, how do we expect this to work when there's nothing in our database? But what we can do is mock like the initial data, right? So let's just say this is an array of, let's say, a text of hello and a value of 1. Right, so basically the data format that we expect. And there we go. We see hello showing up right there. Beautiful. That's going to be the basis for our cloud of words. Very, very nice. We now know that works. We can go back to our initial data. Let's not leave it like that. There we go. And then we can also update this state whenever a real-time event gets triggered. Beautiful, dude. Let's implement the field that allows people to actually comment something, their opinion on this topic, right? Let's create a div right here above our closing max width wrapper. That is where we are. And let's give this a class name of maximum width large and a width of full. So it actually does take up that large that we give it, which is 32 rem, 512 pixels. Okay, inside of here, we're going to create a label from our custom UI label component that we installed earlier. And this will say, here's what I think about, and then dynamically insert the topic name. So in our case, that's going to be Redis in this instance, right? And this label is going to get a class name of font semi-bold, a tracking dash tight, a text of large, and a padding bottom of 2. Beautiful. Let's save that. Let's see what happens. Here's what I think about Redis. Okay. And the word is gone again because we removed it, of course. And then right below the label is going to live a div element with a class name of margin top 1, a flex, a gap of 2, and an items dash center. Beautiful. Let's open this up. And inside of here lives an input element from our custom UI library that we can simply import. This is going to be self-closing, and this will get a placeholder, and that's going to be dynamic. So let's pass a template string into the placeholder, and this will say the topic name that we insert dynamically here using this kind of syntax, the JavaScript template string syntax, is absolutely ... to kind of indicate, hey, you can, put your opinion here. And then Below the input, we're going to have a button that will allow the user to submit this. By the way, we also get this from our custom components UI button, if you're wondering. And let's say share in here. All right, now this button is going to get, actually, let's just save this and see what happens. There it is, right? We have the input in the share button. Beautiful. And now the logic to capture the input and to submit the input to this cloud of words is actually pretty simple. And very similar to what we've already done in the topic creator, if you remember, right? So step 1 was to keep track of the user input that they type right here in state, right? That's just number 1. So let's create a state for that. Let's call it input and set input. And this will be equal to use state. And by default, let's leave this as an empty string and also tell TypeScript, hey, this will be a string. But again, that is optional. If you want to do it, do it. I like to do it. If you don't want to do it, just omit it. It doesn't really matter. And now to make the input controlled, let's pass the input as the value. And of course, also the onChange handler, where we can destructure the, and I keep messing up the syntax for the onChange. There we go, where this is a callback function where we can destructure the target and simply set the input to the target.value. So whatever the user currently is typing into the input field. Right? And now to actually submit this to our cloud of words into our database, well, you know the logic of how this works. We're going to do that with React Query once again, because that is by far my favorite data fetching pattern or data submitting mutation pattern, whatever you want to call it, right? Where we can destructure from the use mutation hook and simply pass it the mutation fn, the mutation function that we can also create in our actions file. Right, so let's close out of the pages. Let's head into our actions file where our server actions live. And let's in here create a new action that's going to be for submitting a comment, right, on a page. Let's create it. Let's say export const submit comment is going to be equal to an async arrow function. So we can do some awaiting inside of here. And this will receive 2 parameters. First off, the comment, and secondly, the topic name. So what did the user write and for which room did they write it? And we can simply inline the types right here. They're very straightforward. The comment is just going to be the string that the user wrote right here in the input field. And then the topic name is also going to be a string that is like Redis in our case, the room name that we have right here. Beautiful. Now to store the count of words, let's say hello world. This would be 1 for hello and 1 for world. If you can see that, maybe it's a bit small for you. To store the counts in our database, we need to know what are the frequencies for each word that was, comment, there we go, that was submitted right here. And in order to do that, we're going to declare a very simple utility function right above our submit comment right here. Let's name it function word frec. And this word frec, the word frequency, I believe we can actually, did I not get that from Airbnb? I'm pretty sure I did. Yeah, there it is right here. If we head over to the Airbnb kind of documentation for the word cloud. So if I take a look at the URL, it's airbnb.io/visx/word cloud. This is where I stole the word frequency function from. We don't need to write it from scratch. You can just grab it from here. It's called word frec, and we can simply paste it in here. But if we do paste it, then we do want to review the logic, what this does, right? Basically, we are creating an array by splitting all the words at their space bars, so at empty spaces. And then we create a frequency map, which is just an object where we map a string, so the word to a number, how many times it occurred in the string, right? And then we're mapping through all the words in the initial string and incrementing the frequency map at the index of that word, right? Essentially, what we end up with is like hello would be 1 and world would be 1 as well in that frequency map that we create if the input was hello world. If it was hello world world, then hello would be 1, world would be 2. I think you get the idea, right? It's pretty simple. If you've ever worked with JavaScript, this will make sense intuitively to you. And now instead of the word data type, we can simply say this is going to be, a text string and value number array as we did earlier as well, right? So TypeScript will be happy. Beautiful. Okay, let's just leave the example there in case you want to look at it. And let's continue in our submit comment function. All right, so first thing we want to do is get the actual word frequencies. Let's say const words is equal to word frec, and we're gonna grab them from the comment. There we go, so whatever the user submitted into here. And then we're gonna say await promise.all, so we can execute multiple promises at the same time. And that's gonna be words.map, so for each word in or array, right? We're gonna execute some logic where that's going to be asynchronous, and we can receive the word in or callback function for the logic that we're about to execute. And now we want to add those combination of words and their frequencies to our database, right? For this specific room that we're in. So when we reload, when we submit or comment and reload the page, it should still be there. So it's maintained in our database, or it's persisted rather in our database, right? So we're going to say await Redis or Redis client.z add. So we're adding to a sorted set. And this takes three things. First off, it takes the name of the room. So this is going to be the room topic name. So room Redis, for example, that's the name in our database, what we call it. Then it takes the increment of true. So we want to increment the current score. I believe we draw this out earlier. If we add 3 to 3, for example, then we have 6, right? Otherwise, we would by default overwrite the 3 with a 3, so it would remain at 3. If so, okay, maybe that wasn't the best example. Let's imagine this is our database, right? And somebody comments the word Redis, just this word. What should happen is not that the score is now set to 1, because this is just one word, but what should happen is that we add 1 to the previous score that was here, which was 3. So now we won't have 4, right? That's why we put the increment true right here. So we increment the existing values when adding new ones. And lastly, this takes an object where the member is our word, right? The member is our word. And lastly, the score is our word dot value. Oh, and that should be not the word, but the word dot text as the member, right? Because we don't want the entire object, we just want the actual string content right here. Beautiful. What we can also do is increment the served requests, right? We can say await Redis dot increment the served requests. Beautiful. So we can monitor those as well. And the last thing we're gonna do, two things. First off, we're gonna return the comment so we get access to it on the client side. But now the more important thing is that we're gonna say await redis.publish, and that's going to be our first interaction with real-time functionality here. And this takes two arguments. It takes the room that we want to publish to. This is going to be room topic name. That's just what we call our room. And then it takes the message that we want to publish. In our case, that's going to be the words that the user submitted through the input field and their respective frequencies, right? So basically what we got up here from our word frequency function that we are publishing. Now, where do we read whatever we publish? Currently, we don't, right? That's the straight up answer. Currently, we don't. That's what we get to when we implement the real-time functionality, as you're going to see here in a bit. Anyways, what this allows us to do, defining the submit comment function, is it handles all the logic for our database to persist whatever the user input here in the cloud of words format. And it also allows us to now use this in our front end by simply pasting in the submit comment, importing that. And now, as you know this data pattern already, you know that we can destructure the mutate function from here to actually invoke this. And the is pending or the is loading state, same thing from our use mutation. Beautiful. So when do we want to invoke the submit comment function? Well, basically when the user clicks the share button, right? When they want to share their opinion, to bless the world with their opinion, that's what should happen. So on the onClick handler here, we're gonna call the mutate function and simply pass in the comment. That's gonna be the input, and also the topic name that we get as a prop into this component, right? And that's it. That's already it. What we can also do is pass a disabled state into the button. That's gonna be is pending. So when we are in a loading state, this button will be disabled so the user can't spam it. And let's see what happens, right? Let's open up our app. Redis is absolutely great. And let's hit share. And once we reload the page now, there it is. Great. Redis is absolutely, stinky. Let's hit share. Let's reload our page. There it is. And if we now type great again, what we expect to happen is for this word to be way larger than stinky, right? So let's reload our page. And there it is. Beautiful, dude. Very Very, very nice. We now have a voting functionality. It's not real time just yet, right? This is not updated in real time to any other clients that are connected to the room, nor to us, right? When we hit share, that's not how it works yet. But the main functionality, the bag or the cloud of words, I guess it's called, works super, super nicely with a clean grid pattern background, and it just looks good as well. Okay, dude, very, very nice. And now the last step is to actually make this real time, right? So multiple clients can connect to the same page and submit their comments, and it's shown to everyone at the same time while also being persisted in the database and so on. And that's gonna happen not in our client, but actually in our server. Right here, that's why we created that. So let's quickly give VS Code a bit more space. And let's clear our terminal and cd ... and cd into our server directory. Oh, we're on the desktop. Let's navigate into, what did we name this? The Scalable Redis. And then let's go into our server. There we go. So we're in this directory in a shell, right? Great. So we're going to do two things to initialize the server. First off, npm init-y. And that's going to create our package.json. And the -y just means that we say yes to basically all the default options that the package.json gives us. And then secondly, we're going to say, actually, no, what we could do is say tsc --init. And let's try that. But that creates a super long, super unnice to read tsconfig. So let's just write this ourselves really quick. Let's open up an object and pass the compiler options. Where the module is gonna be common.js, the module resolution, let's set that to, there we go, node. The pretty, let's set that to true. The resolve JSON module is gonna be true as well. Then the ES module interop is gonna be true. And by the way, if you don't know what all of these mean, that's fine, right? Neither do I, honestly. You normally just copy and paste this or let the compiler do the work for you, the tsc init. Anyways, let's say allow synthetic default imports. We're going to set that to true. The source map is going to be true as well. The target for the translation or compilation, whatever you want to call it, is going to be ES2017. Then the outdir, where our build files, the final output will be put, is going to be /dist, which stands for distributables. It's just a convention to name your final output. In Next, I think that is also called like build. Yeah, well, we haven't built our app yet, so I can't show you, but that's just a convention. The base URL is going to be ./lib, and then the lib option we can set here is going to be ES2017. That's going to be an array, by the way, of strings. Then DOM and also ES next. There we go. And we're almost done. Last thing outside of the compiler options, the include, let's set that to */*.ts. So basically we want to include any TypeScript file in our entire server folder into this tsconfig, and we're going to exclude the node underscore modules from type checking. So if there's any type errors in the node modules, then well, that's not our problem, right? We don't really care about that. Beautiful. Okay, now let's create an index.ts. Let's get to the actual fun part, right? Nobody likes writing tsconfig. It's just not fun, but we are done with that. I'm going to pull it up in case you missed anything. And then let's actually start in our index.ts, right? The fun part. Great. Let's exit out of this. And we're going to install a library. Before we get started, let's say npm install, and that's going to be the library we use to interact with WebSockets. That's going to be socket.io, super popular WebSockets client that we can use. While we're here, we can already install Cores as well, which is cross-origin resource sharing. So we can basically access our server from our front end. And we're also going to install IO Redis and .env. And lastly, Express, right? So we have socket.io for the WebSockets, Cores, so we can manage cross-origin resource sharing, IO Redis to connect to our Redis instance via TCP and not HTTP, like the Upstash Redis client allows us to do, .env to access environment variables, and Express for our web server. And then hit enter. I know 5 dependencies are quite a bit to get started, but most of these do just one thing, like Cores or .env. You barely will notice that we even have them in our project. So let's give this a bit less space. There we go. Now, how do we create a web server? It's pretty easy. Let's say const app is going to be equal to Express. And that is why we installed Express, right? It allows us to create a web server really, really easily. We can simply import Express from Express. And that probably, yeah, it doesn't know the types just yet. That's fine. Let's install some types just so we can work with TypeScript smoothly. Let's say npm install -d for a development dependency, because we don't need that in production. Add types/express. And also while we're here, add types/node, which is basically the Node.js runtime types like the process.env, for example, that we're going to use in a bit. Awesome. So let's reload our window. Let's see if that worked. And ideally, we should not get an error. Cannot find module express, or it's why is it doing that? Oh, and that's because we put our index.ts file not inside of our server directory, but inside of our main root directory where we don't want it to be. So let's move that into the server directory. There we go. And now everything works, because now it pulls from our tsconfig, so it can resolve the types that we need to work with. Beautiful. Okay, let's also say app.use course, and course is just a middleware that we can use right here, that we can import also at the very top, import course from course. And if you've ever worked with Express, this is nothing special to you. Essentially, it just means we can now access our app via any URL, like localhost, where we host our frontend app, right? That's really all it does. Let's create our server. Let's say const server is going to be equal to HTTP, which is also a built-in thing in Node from the standard library. We can simply import HTTP from HTTP to create an HTTP client, or server in this case. So we can call the create server function on here and pass in our Express server, so our app. And what that allows us to do is to now create a WebSockets server. So basically a real-time communicating server that we can use to connect to our front end, right? So we can say const io is going to be equal to a new server. And where does the server come from? Well, basically from our WebSockets library, which is socket.io. So we can go to the very top and simply import server from socket.io. And that allows us to now spin up a WebSockets server. And as the basis, right, this takes, you can see that right here, it takes some options and it returns a server. As the basis, it takes our HTTP server that we created, and it also takes some options if we want to. These are optional, that's why they're called options, right? But we can pass some core settings in here so we can actually access this from our front end, because by default we couldn't. This takes an origin, and let's set this to an array. This could also be just a string, but let's put this to an array in case you wanted to allow multiple origins, for example, if you deployed this. And the default one is going to be HTTP localhost 3000, where we host our front end. This also takes some methods that we want to allow. Let's just say get, and let's also allow post for any request. And lastly, this takes the credentials option, and let's set that to true. Perfect. Okay, very, very nice. Now to actually make the server run, that's super easy, right? So when we run this file, we want to start up the server. Let's do that. First, we need the port. We need to determine which port this runs on. And this is either the process.env.port if you deploy this, right? This will be provided to you by your deployment provider, or we're going to set this to 8080, which is just a standard kind of server port. This could be anything as you want. I like to do this as 8080. It's just a convention, but it's not like, you can definitely change it if you want. And lastly, we're going to call the server.listen, and to actually spin up the server, pass in the port that it should run at. And this takes a callback function. And inside of this callback function, we can simply log out that our server is running. For example, let's do this as a template string. Server is listening on port. And then let's pass in the port right here that we spun up the server on. Beautiful. Now to run this file, how do we do that? Can we just call node index.ts? No, not really, right? To load an ES module, blah, 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 it doesn't work because this is a TypeScript file and by default Node doesn't know that. That's why we can install a super easy package, npm install -d as a development dependency, tsx, and literally the only thing that this tsx package does is it lets us run TypeScript files. So when we say, for example, yarn tsx or pnpm run or npm run tsx index, bam, or maybe it's not npm run, it's npm tsx index. Does that work? Well, I always use yarn for this. I don't know what the command is for npm. npm run tsx. Well, I just use yarn. Maybe you could also say pnpm tsx index. Does that work? Yeah, that also works. npm just sucks. That's why it doesn't work. Maybe there's a different command for npm. I don't know. But pnpm tsx index or yarn tsx index, all of it works. And basically we can just spin up our server on port 8080. So now it's listening and it's ready to communicate with our front end. Beautiful. And now what should happen when somebody connects to our real-time server, to our WebSocket server from the front end? We can handle that case by saying io.on, and this takes a connection string. So what should happen on a connection event, right? This takes an asynchronous callback function where we can define any logic that we want to handle when a WebSockets client connects to our server. This is basically like an incoming HTTP request, but for WebSockets, right? So it's a different protocol, but essentially an incoming request. How do we want to handle that? And this gives us access to the socket, so the incoming request object, basically, right? So this has, for example, an ID that we can destructure. Let's destructure the ID from the socket, and this is the unique user ID of the socket that makes the request that we can then use to store it in our database, for example, right? And the way that we architect this app, we have different rooms. For example, Redis is one room that we have, or basically any topic that you create is one room. So an event that we are going to define is going to be socket.on, and let's call this join room. This is an event we can now fire from the front end, from Next.js, and listen to it in our back end and determine inside of a callback function how we want to handle the logic that should happen when a user joins a room. And this is going to be an asynchronous function, so we can do some awaiting in here. And this also takes the room, and that's going to be a string. Why does it take that? Because that's what we're going to pass from the front end. This just takes the data that we pass from the front end and accepts it on the back end. It doesn't know what kind of data that is, so we need to tell socket.io this will be just a string that we're going to pass in, right? And for now, we're just going to log user joined room, and then let's also pass the room right here. And I think before going any further in the logic on the back end, let's try to connect to a room from the front end, right? So how we do that, it's going to be inside of our client page. And by the way, let's give this more space and let's give this less space. There we go. Yeah, sometimes window management on Mac is kind of ass. Anyways, and let's connect from our front end. How do we do that? Really, really simple. There's an equivalent of the socket.io library that we use on the back end to connect from the front end, basically, right? So let's navigate into our client. Let's quickly stop the development server. And let's say pnpm install socket.io -client. So this is the client equivalent that makes it super easy, as you're going to see, to connect to our running server from our front end. So how we do that is let's import io from socket.io/client or client-side library. And let's define a const socket is what we're going to call it. Is going to be equal to io and simply pass in the connection string. So where is the WebSocket server running? In our case, because we set the port to 8080, we know where it is. And that's HTTP, there we go, localhost 8080, right? So where our server is running. If you deployed this could also be your deployed version. Same thing, right? It really doesn't matter. Both local and deployed version is going to be the exact same thing. And dude, that's almost all we need to do to connect to our WebSocket server. The only thing that's left is let's create a use effect inside of our actual component. And let's make it so this use effect only ever runs once, and that's in the initial render, right? So we're going to leave the dependency array of the use effect empty. So it will only run once. And inside of here, we can now call the socket.emit. That's how we trigger an event on the server that we connect to. And now let's can we do this into a side-by-side? Yeah, we can. Let's try this. But I want the client to be on the left, and let's move the server to the right side so I can show you what happens here. So if we connect to our backend server, then we are connected to the IO, right? IO.on connection. So we're listening to changes from the front end on the back end. And when we now fire an event on the front end, let's say, for example, socket.emit join room, join-room, Because we have a persistent TCP connection open to our backend server, to our WebSocket server, if we trigger an event that matches in name, now we are listening to that same event on the backend, right? So when we trigger an event from the front end, we listen to it on the backend, and we can handle the logic accordingly on the backend. That should happen, right? That's literally all it takes. And any data that we pass into the emit event, for example, let's pass a string right here. That's gonna be room, colon, and then the topic name. This data that we pass in here is then automatically going to be received on our backend right here as whatever is inside of the callback function, right? This data will be this room right here, and we can now handle the logic. That's how we transfer data from the front end right here to the back end right here and handle the logic accordingly, right? And if we start our server and our client, we should already see this working. So let's try this. Our backend is running. Let's start up our front end. Let's move this into a side-by-side. So let's give this a bit more space. Let's reload our Next.js page right here. And we now should see on our server that we connect from our client, because we are connecting right here. Is that correct? Yeah, that should be right. So let's reload our page. And ideally, we should see in our server logs that we connected. All right, but we don't see that. Let's quickly restart our server. Why do we not see that we connected? Let's try this again. And why do we not see, oh, yarn tsx index. Okay, let's start up the index file of our server. The server is listening, good. And there we go. If we now restart the page, then we can see that the user joined the room. And the reason we didn't see that earlier is because we changed something about the file and then did not restart the server. To make that automatically happen for us, right, that's much better, is let's define a dev script in our server package.json. So if you're wondering where we are, server package.json right here. Let's define a dev script, and that's simply gonna be tsx watch index. And this watch will actually watch changes in the file, and once it changes, our dev server will automatically be restarted. So when we now say npm run dev, for example, or yarn dev, and whatever it is, then any change that we make in our server file right here, let's console log something and save that, automatically, bam, there we go. Our server was restarted, and we don't need to worry about it. Perfect. Very, very nice. Beautiful, dude. And next up, let's connect to our Redis instance on the server. That's going to be really important because almost all of the logic that we're going to handle on the server is going to connect to Redis. That's what makes this so scalable, that we can outsource the core logic to Redis, and then the server that hosts the WebSockets are insanely scalable, right? You can just slap a load balancer in front of these and have as many as you want, because the WebSockets connection are replaceable. The core logic in our database is the hard thing to scale, and that's all taken care of by Upstash, right? So this is very, very scalable horizontally, meaning you can just add more servers and scale accordingly, right? I mean, even with one server, right, you can get easily to 10,000 requests per second, for example. It takes you very, very far. And only as you get like a ton of users do you actually have to worry about scaling. And in this case, you don't really have to worry about it either, because it's pretty easy. Okay, now to connect via a TCP client to our Redis instance, where was that? There was an option somewhere. Right here. We can click node when in the connect to your database kind of area here, and that's going to give us a connection string that we can just go ahead and copy. So let's click on the eye icon and grab the connection string right here. For some reason, it's kind of clipped out of the screen, which is not good. Maybe we need to fix that, because I work at Upstash. Maybe I should go ahead and fix it. That's not good. But anyways, we can just grab the connection string right here and go ahead and create a .env file in our VS Code, because we don't want to put this as a string in our file, right? That's security-wise not a very good idea. Let's instead create a .env file where all the sensitive information will live. And let's name this the Redis connection string. There we go. Simply paste that in, and we can remove the trading kind of quote that we have there. So we have something called Redis, which stands for Redis secure, right? Just like HTTPS. This is Redis S. And then the connection string that we have with a default Redis port here at the very end. Beautiful. And that allows us to actually connect to Redis from our backend as well, to the same Redis instance that our front end also uses, right? And the way we do that is surprisingly simple. We can simply instantiate a const Redis is going to be equal to a new Redis and import that from IO Redis right here. And this takes one thing, that's just the connection string. So the process.env.redis_connection_string. There we go. That's it. And we're gonna copy this line down using Shift, Alt, and arrow down once. That's it. And this is what we're gonna call the sub Redis. And there's a good reason why we're creating two Redis clients right here. Before I explain you more about it, let's kind of move this into a side-by-side again. Let's open up our app. There we go. And the reason is that the normal Redis is going to be there for normal data interactions. For example, if we wanted to increment a field on a hash, or if we wanted to add an item to a set, and so on, that's what the normal Redis is for. The sub Redis is going to open a persistent connection via TCP to our Redis instance, right? This is going to stay open. And that's a quirk of Redis. If you leave a connection open, like a subscription, for example, then you cannot use that client for anything else but subscription commands, right? So we have to have two instances. The sub Redis, once we subscribe to anything, cannot run the commands of the normal Redis instance anymore, right? And that's the reason we open two connections and not just one. Perfect. Okay, so what should happen when a user joins a room, as we just did, right? As we just tried out, when a user goes into a room to share their opinion. A couple of things should happen, right? First thing, let's say const subscribed rooms is gonna be equal to await redis.s members. So we can get the members of a set, and this only takes a name, right? The name of the set where we want to get all entries from. Let's say subscribed-rooms. Why are we doing this? Basically, we're gonna keep track of all rooms that we have subscribed to inside of a set. Therefore, we don't want to subscribe to one room multiple times, right? If we're already subscribed through our Redis instance, we never want to subscribe to one room more than once. That would be a complete waste of connections. And you're gonna see what we do with the subscribe rooms here in a second, right? Before we get there, let's do something else. Let's say await socket.join, and we're gonna join the room. And that was passed as data into our join room event that we trigger from the front end, right? And that's how we let socket.io know that this socket, the current user, is now joining the room that we want them to join. Because there's a concept of rooms in socket.io already, right? There's something called socket.rooms that's built in to socket.io, just for your information. It's just nice to know. Awesome. Next up, we're gonna say await redis.sadd. We're gonna add to a set, and the name of the set that we want to add to is gonna be rooms and then the ID. So we're keeping track of the current user and all rooms that they are connected to, right? So we're gonna add the current room that they just joined. So when I, for example, join Redis, then rooms and then my ID is gonna contain Redis as a set, right? So let's say user one, and their set right here, the rooms they're connected to would be, for example, like Redis. And if they were in multiple rooms at the same time, let's say they were also in the Next.js room, there would be two items in the set right here. So we're keeping track of all rooms that this current user is connected to, right? And lastly, we're gonna say await redis.h_incr_by. So a hash increment by. So we can increment one value of a hash. And the hash name is gonna be room-connections. The field name that we want to increment is gonna be the actual room name that's passed into here. And then the increment by is gonna be 1, because we're keeping track of one connection. What this will do is we're gonna have a long list of all rooms in our entire application, right? Redis, there's gonna be Next.js, all rooms that users created, and how many people are currently, right now, connected to that room. For example, 5 people are in the Next.js room and 2 people are in the Redis room. By the way, all of this is gonna become very clear once we actually run this code and I show you in the Upstash dashboard. But just so you know what this is while we do this, this will contain all the connections for all rooms in our entire application, and that's just really good to know, right? And now for the reason we did this check, the subscribed rooms, because we never want to subscribe to one room more than once. So only if not subscribed rooms dot includes the current room, only in that case do we want to subscribe or open a subscription to that room to real-time updates to our Redis data, right? So only in that case are we gonna call the subredis.subscribe, which is a blocking command, right? This works over TCP, not HTTP, and therefore we need IO Redis to do it. And we're gonna subscribe to the room, and this takes an asynchronous callback function. which optionally gets an error, right? If anything goes wrong during the subscription, hopefully not, right? But if there is an error, in that case, we're simply gonna console.error that, let's say, failed to subscribe. Let's also log that error. But in most cases, nothing is gonna go wrong, right? In the ideal case. So what if we successfully subscribed or Redis instance to that room? Well, basically, we can just say await redis.sadd. We're gonna add to a set, and we're gonna add to the subscribed rooms, right? You see the pattern here. We check if we are subscribed to a room. Right here, if we're not, we open the subscription, but then we add to the set. So if another call comes in that wants us to subscribe to the same room, right, we're not gonna subscribe again because the room is already going to be in the subscribed rooms. And this, as the data that we want to pass in here, is simply gonna be the room. And that's also just for us. Let's console log subscribed to room and then put the room here. Beautiful. Very, very nice. Let's see if this works. So what we expect to happen, let's go into full screen here and let's open up a split view of upstash.com where we have our kind of data browser on the right hand side. Let's go into real-time voting, data browser. There we go. Let's try this out. Let's go to the homepage, for example, and let's go into, oh, that's not the homepage. There we go. Let's reload our page and let's go into the Vercel room, for example. Let's hit create. What do we expect to happen? There should be a Vercel under the existing. Actually, you know what? We can just flush the entire database. Let's say flush all in the CLI. That's going to delete the entire database. And let's just go to localhost 3000 so we have a fresh start, right? There's no data. Let's try this out. Let's go into the Vercel room, for example, to share our opinion about Vercel. There we go. Let's reload this. And there's going to be the existing topics of Vercel. Beautiful. And we incremented the served requests. But what should happen, what doesn't happen, let's reload our data browser, is we do not see the information from our backend that we created, right? Oh, and okay, we got an error. And I can tell you right now without even doing any debugging what the problem is. The problem is that this string is undefined because we forgot to import .env/config. If we do not do this, then our Node.js runtime won't have access to our environment variables. So we need to import .env. That's exactly why we installed it in the first place. And now let's try this again. Let's reload our page right here. And now, there we go. In our data browser, we can see that we have opened a connection to Vercel. We haven't handled the case yet where we disconnect, right? So this is more connections than we actually have, of course, right? Because we're not deleting connections yet once we disconnect. But we can see that this was created successfully. We're keeping track of each user and their socket ID and which rooms they are connected to. Beautiful. And the existing topics and the served requests as we had before. Very, very nice. Let's kind of move out of the side by side. There we go. And now, of course, we also need to handle the other case, right? Not only where we connect, but also when we disconnect from a socket. So for example, when we close the web browser, right? What should happen when a user disconnects from their room? And the logic is going to be pretty similar, but just the reverse of the join room, essentially, right? So let's say socket.on and then the disconnect event. What do we want to happen in that case? It's going to be an asynchronous arrow function once again. And inside of this function, let's destructure the ID from the socket first things first, right? We need to identify the currently connected user. Then let's see which rooms they are connected to, right? Let's say joined rooms is going to be equal to await redis.s members. So all entries in a set, that's what we're doing. And the name is going to be rooms:ID. So which rooms is the current socket connected to? Like Vercel, like Redis, and so on. Once we got this data, we can already scratch the set that the user is connected to because the user is now disconnecting. We don't need the set anymore. We can simply call await redis.del, which stands for delete, and delete the set called rooms:ID, right? So we're keeping track of all the rooms that the user is connected to. Now we don't need to anymore because they are right now disconnecting. And then for each joined room, joined rooms.for each, right? We want to execute some logic. This takes an asynchronous callback function where we can just get access to the room inside of here. And now what should happen for each room that a user is disconnecting from? Well, we're keeping track of the connection count for each room, right? If we reload this, you can see the room Vercel right now has 4 open connections. Again, that's not true because we didn't count the disconnects, but you get the idea, right? We're keeping track of all the open connections to all rooms. And if a user disconnects from a room, of course, we want to decrement the connection count again. Therefore, let's say const remaining connections, there we go, is going to be equal to await redis.h_by. And this takes the name of room-connections, basically what we named our hash, where we're keeping track of all of this. Then it takes the current room, and lastly the incrementation by, which in our case is going to be -1. And interestingly enough, the result of this operation, so after we decrement, is going to be the current number. So if we decrement from 4, -1, because one user just disconnected, right? So there's 3 open connections. That's going to be the result of the operation. That's going to be 3. So the new number, right? Basically, it's going to be how many connections are there left on this room. And if the remaining connections is smaller or equal to 0, it shouldn't be smaller, but let's just handle that case as well. It doesn't hurt to handle. In that case, that means this was the last user in the room that just disconnected, right? Therefore, what we can do is just close the subscription altogether. There is no more people in the room. So let's say await redis.hdel. So we're deleting from a hash the current room, right? From our hash where we keep track of all rooms and all their connections, because there is no one more in this room. Let's say room-connections as the name, and let's delete the room from our hash. And also we can now unsubscribe. There is no more people in the room, so no point keeping the connection open. We can call subredis.unsubscribe, and we can unsubscribe our client from the room. And this takes a callback function. Once again, you kind of know the drill by now, right? This takes an error object. If anything goes wrong, if there is an error, let's just say console.error failed to unsubscribe and log that error. So in this case, for example, we would be able to see in our runtime logs, wherever we deployed our server, for example, or in our console, if we're running this locally, that anything went wrong, right? But in the other case, that's going to happen in, very much most of the cases where everything is going to go well. We can do await redis. There we go, redis.srem. So we're going to remove an item from a set. And that's going to be the subscribed-rooms. And we want to remove the room, because when now another request comes in to subscribe to the room, then we can open another connection again, right? As long as it's not in the subscribed rooms, which is the same set that we are removing from right here, right? And then let's just console log unsubscribed from room. And let's also attach the room right here, just so we can tell what's going on while we do this. Beautiful. So that's the core logic done. When we connect to a room, let's open up the server right here. Let's go into here and let's reload our page. User joined room Vercel. Beautiful. By the way, if you're wondering why does this happen twice, that's because of something called strict mode in React that by default fires the use effect twice. If you wanted to, you could disable that in your next.config. You can pass React strict mode false. The purpose of strict mode is to kind of catch errors during development, but it can be kind of confusing because in production it behaves differently than in development. So once we set this to false, you're going to see when we reload this page, like right now, there's only one connection as if it was in production, which is the expected scenario, right? Where one person only opens one connection. Perfect. Beautiful. So what happens architecturally now? Right, let's go into Scalable, is that when, let's say we have our input right here, right, where we share our ideas. I want to quickly sketch this out for you. We have the input, we have the button, right, that says submit. Once we submit our idea, this triggers a server action, right? This triggers a server action that updates our Redis with the data of the input, right? So where do we, let's put our Redis up here. Let's say Redis. And if you remember, we publish this action as well. So if we go into our front end, right, we say redis.publish, and that's exactly what our server can now listen to. So whenever we publish a message, right, it gets forwarded to our server, and we can now distribute it across all connected clients. So when there's, like, for example, there's U1, which stands for user 1. Let's just say these are different people, user 2 and user 3. What the result will be when user 1 submits something to room Redis, for example, their message is submitted into the room right here, essentially what's going to happen is that this event will now be distributed in real time, not only back to the same user, but also all the other users that are actively connected to the room. And the same thing goes if user 2, for example, submitted a message, right? That will then be distributed to the other users and so on in real time, and also maintained or persisted rather in our Redis database. All right, so that's conceptually how the real-time functionality works. When one user submits a message, that gets sent to our server or WebSocket server, and we've set up all the connection stuff. The only thing we haven't implemented yet is the distribution. How does one message get sent to the other users, like user 2 or user 3, and so on? So this part we haven't implemented yet, right? Our message gets to the server, we've received it there. Now the only thing is to distribute it to the other users, and that's way simpler than you might think it is. Let's open this up in a side-by-side. Let's navigate back to our app right here. It's much simpler than you think it is, and it will happen right above our io.onConnection in our server file. So what we can do is call the subredis.on message. So whenever there is a message sent to our server, we can now redistribute it to all connected clients. And we do that by saying io.toChannel. Where does this channel come from? Well, we can basically grab it right here in the callback function that we get. And we also get access to the message that we want to relay to all connected clients, right? We can simply call the io.toChannel, so the current room that the message is being sent in, .emit, and we can emit the room-update event and then pass the message as the data. So the message is going to be whatever one person that's connected to the room typed right here, their words and their frequency, right? That's what we relay to all the other clients. And we are only broadcasting it to the single room that the users are in, right? That the message was sent in, right? So let's save that. And by the way, while we're here, we can also handle the error case. If anything goes wrong, subredis.on error, right? In that case, we get access to the error also in the callback function. Let's call this error, and we're simply going to say console.error, and let's say Redis subscription error, and log out the error right here. Right, that shouldn't happen, but if it does, we know what's wrong. And dude, now the cool thing is, just like there's an event we can trigger on the front end and listen to on the back end, like the join room, when we trigger a room update from our backend, we can listen to it on the front end, right? That's how we achieve full duplex communication, right? To the server and back to the client, right? How do we do that? That happens inside of a use effect on our front end. And we can now listen to an event in here. Let's pass an empty dependency array for now. And what we can simply do is socket.on and now listen to the event that we want to, well, basically listen to, right? In our case, the room update event that is triggered from our backend when we want to relay a message to other users. So we can simply pass in the room update right here. This gets access to all the data that is sent from the backend. In our case, that's going to be the message that we put in right here. That's what we're going to receive as the callback function, which we know is just a string. And then for now, let's just kind of console log room update received with the message right here, just to kind of see if this actually works. Because what we expect to happen now, let's go into full screen here and let's kind of flush our entire database. Let's have a fresh start at this. Hello, can I click that, please? There we go. Flush all. That's going to delete our entire database. And then let's go to our localhost 3000 and let's open up two instances here. I'm going to go to localhost 3000 / I don't know, Redis on the second one, and then also go to Redis on the first one. So we're connected both to the Redis room, right? So there should be two connections now. Let's see if that's true in our server logs. Do we have two connections? Yes. User joined room Redis, user joined room Redis. We are subscribed to the room Redis as well. Beautiful. Now, what do we expect to happen when we send a message on one client? When I type something in here and now hit share, we expect it to be logged on the other client's console, right? Because of the console log we just inserted whenever we trigger a room update right here. So what we expect to happen is to see room update received in the console of both clients. So let's try this. Redis is absolutely great. Let's hit share. And there we go. Room update received, text great, value 1. what we typed on the left client inside of the right client. Beautiful. And we should see the same console log on the person that typed it, by the way. There it is. Very, very nice. So now we implemented the full duplex connection that I just talked about, right? So not only can we communicate messages to the room, to the server, but we can now also send that message to all clients that are connected. Dude, that's awesome. Really, really nice work. And that's the most important part of the logic, literally already done. If we give this a bit more space, there we go. The only thing that's left to do is to actually update the cloud of words in real time, right? Because right now, only if we actually reload the page, let's reload them, do we actually see the changes in the cloud of words or cloud of words appear, right? And of course, that should happen in real time as well. How do we do that? That's the easiest part, right? We're almost done. Very, very nice. We already know what we receive, right? We saw in our console, we had like the, where was it? Let's say anything here, share. We have the text and we have the value of how often that word occurred, right? On every connected client to the room, which is literally all we need. So we can simply say const data is gonna be equal to json.parse message, because this is a JSON string, and we can cast the type as a text string and a value of number, which we know this has because that's what we send to the backend. Right? So just like that, we can, oh, by the way, this needs to be an array, right? It's an array of those objects. Beautiful. And now let's say data.map. And for each new word that we want to now merge into our local state, right? That's how we achieve the real-time UI updates. We can simply execute some logic. And the first thing we're going to do in here is check, is this word that we are just receiving from the other clients already included in our state? And if it is, then we're just going to increment the count for that word. And if it's not, then we're going to add it to the state. Maybe sounds a bit abstract, but trust me, it's very straightforward. Let's say const is word already included in our state is going to be equal to words or state dot sum, which basically checks a condition for any element in the array. Right? So for any word in the array, we check if the word.text is equal to the new word.text. So for every incoming word, is it already in our state? And if it is, right, if is word already included, it's already in our state. In that case, we just need to increment the count for that word. We don't need to add it again, right? So let's just make a comment here. Let's say increment. In this case, we're going to set the words to whatever they were previously, right, that we get access to. And what they were before, let's save that as const before, is going to be equal to previous.find. And for each word, we're going to return the word.text is triple equal to the new word.text. So the word already exists in our array, and this is the element that contains the word that already exists, right? And we can also get access to the rest because that will remain unchanged. We're going to say const rest is going to be previous.filter. And for every word we have in this array, we're going to check if the word.text is unlike the new word.text. So it's basically the opposite of the before element, right? Because we only want to change the before element, but nothing about the rest. That is why when we return, we can simply return an array. And first off, just spread in the rest. We don't care about it. We don't want to change anything about it. But we're going to put in one more object, and that's going to be the text. And that's going to be our before.text. And TypeScript is probably going to complain that the before doesn't exist. We know this exists, right? Because we did the check. Is it in the array? Yes, it is. Only if it is do we actually get to this point. So we can simply put an exclamation point here to tell TypeScript we are sure that this exists. And then the value is going to be the before exclamation point dot value +1. Oh, and not +1, because that wouldn't account for if we had a word multiple times, like Redis, Redis, Redis. We would still only count Redis once. That's not what we want. This should be the new word.value. There we go. Beautiful. And that is the core logic done. Now, the other case, if the word is not already included, if it's not in the state, in that case, we can just add it to the state, but we're only going to do that else if under one condition. And that condition is going to be really simple if the words.length is smaller than 50. We don't want our state to become extremely long, way too long for the client to render, and because that's going to slow down the browser and so on, we don't want that to happen. So by simply adding this condition, we can completely prevent that. Easy, right? And then in this case, we can simply add to state. Let's just have it as a comment here. I think it's more readable. And let's set our words to whatever they were previously. Let's receive that and create an array where we spread in all the previous elements and then the new word, right? And that's it. The only thing we need to do now is to clean up after ourselves. Right here, we have something called socket.on. And just like you need to remove event listeners after creating them in a use effect, we also need to trigger in the return statement of the use effect right here, which takes just a callback function. We simply need to put socket.off room update to kind of clean up the listener, right? And lastly, we're going to put the words right here in our use effect dependencies. So we actually get the correct versions of our words wherever we use the state, like for example right here, right? Because our use effect logic depends on that state. And that's it, dude. That's literally it. Let's save that. Let's move into full screen and let's take a look at this. So let's give it a completely fresh start. Let's exit out of this, and exit out of this. Let's flush our database and give this a final shot. And now this should all work in real time. Let's see. So let's go into a split view. Let's go to localhost. And we can even add another split view maybe. Is that possible? Convert to vertical. Well, okay, seems like you can't go into 3-tab split view in Arc in the browser that I'm using. Anyways, let's open up localhost and let's also open up one more localhost in a split view right here. And let's just go to localhost. I don't know. What do we want? Which room do we want to connect to? Let's just say Redis, right? And let's also connect to Redis from our front end right here. So we have 2 connected clients to Redis. Let's see if our database reflects that. Let's go into room connections. Room Redis has 2 active connections. Exactly, right? We keep track of both connected rooms or socket IDs and their connected rooms. And we have all subscribed rooms right here, which is only Redis for us, right? Very, very nice. If we now say something Redis is great in room 1, oops, we should see that in real time. Beautiful in room 2 is awesome. Let's click share in room 2 and we can see that in room 1. And if we say great now, then we expect it to be much larger than the other words. Let's try that. And that works super smoothly. Very nice. Very, very nice. Now what happens when we disconnect from the room? Bam. Now only one connection should be open in our database. Let's refresh this. Bam, there we are. 1 active connection to room Redis. Perfect. And if we now disconnect from the last connected client right here, bam, let's disconnect. We should see that the hash is gone altogether because nobody is connected to any room, right? And if we now connect it like to room /Vercel for, well, I misspelled it, but we should still see that in our database. Let's share that. Let's reload the page. Of course, this is fully persisted in our database, right? So that works as well. Beautiful. And we should see Vercelo in our database as a room, right? Because one person is currently connected to that room, Vercelo. Very nice. This is the actual content of the room. This is how we persist the actual content. Nice. And once we disconnect from the Vercel room and reload our database, there we are. The hash is gone. Served requests, we're keeping track of all of it. And this is shown on our front page, right? So this should show 10 served requests because if you remember, we are rounding up the requests. Dude, amazing work. We just made a super scalable, real-time, beautiful voting system from scratch together in Next.js. You did some amazing work. This was a ton of fun to build, and I really hope you learned a lot. This was such a cool project to build and to share with you. Thanks a lot for following along. I really hope you enjoyed. And I'm going to do the outro in person right now. Thanks a lot for following along, and see you in a second.